Hello everyone. In this video we will understand one example that is based on looping. I have already discussed the concepts of looping or iteration in my other video. In this program we'll solve this problem using looping or iteration. So design and develop using an iterative problem solving approach for Taylor series to determine sin of x, right, which is given as x minus x cube divided by 3 factorial plus x to the power of 5 divided by 5 factorial, x to the power of 7 divided by 7 factorial, 9 divided by 9 factorial, and so on up to x to the power of n divided by n factorial, right. Now if you observe the patterns here, the first term is x to the power of 1 divided by 1 factorial minus x cube divided by 3 factorial plus x to the power of 5 divided by 5 factorial and so on. So first thing you have to observe here, there is alternative change in the sign. So if the first term is plus, the next term is minus, the next term is plus, and so on. Whatever power of x is there, the same number factorial we have as a denominator. Okay. Now this is cumulative. So you have to determine something called as sum. How many number of terms you will have? You will have up to n terms. You have to find the sum of these n terms. The more number of terms you have, you will get the approximated or nearer value to sin of x. This is one thing. Second thing, the value of x should be read as degrees from the user. It should be read as degree from the user, and you have to convert to radians before you use it in these terms. So these are individual terms, term 1, term 2, term 3, and so on up to n terms, right. So we will first write the algorithm and then we'll go with the program. Start. Read value of x from user. Third, read value of n, that is number of terms. Okay. Next, you have to convert into radians. So for that I will use compute x is equal to x into whatever value you have read, that into 3.14 pi divided by 180. This will give me a radians, degree to radians conversion. Okay. Next I will do few initialization. The first term is always x, or sum is equal to x. First term is also equal to x, okay. Now I have to repeat the things. Okay. So this problem cannot be solved using conditional statements like if and else, because you have something patterns which you are repeatedly doing. So for that purpose, iteration construct is perfectly the solution. Okay, so I will write the statement as repeat step 7 and 8 for I equal to 1 to n. I want n terms, right? And I have already taken the first term. So your I value will range from 1 to n. Now what is that? Step 7 and 8. Step 7, you will be computing the term. As I told you before, you have alternative minuses and plus. So for that purpose, I will use minus 1 into t, okay, into x into x. Okay, so this will become my numerator. This will become my numerator divided by 2 into I into 2 into I plus 1. We'll trace it. That time this becomes clear to you. This becomes the denominator. So this is our numerator. This is our denominator. Okay. Fine. Step number 8, as I told you, cumulative sum. Sum is equal to sum plus term. I'll just write it as t here. Don't get confused. This is the same thing which I am using here, t. Ninth, display sum, and 10 stop. Okay. Right? We'll just trace that, determining the term. T is equal to, this is a formula, minus 1 into t into x whole divided by 2 into I into 2 into I plus 1. Okay. Now initially t is equal to x, okay, and sum is also equal to x. So what is the sum? Is equal to plus t. Okay, this is a formula that we have written inside a loop. Now let us see how this works. So I will have minus 1 into x into x into x, right, whole divided by, for I equal to 1 it is into 1 into 2 into 1 plus 1. What will this give me? This will give me minus x cube divided by 2 into 1 is 2 into 2 into 1 plus 1 is 3. 3 into 2 is 6. That is nothing but 3 factorial. Where will this be stored? This will be stored into t, and I compute sum is equal to sum plus x cube minus 3 factorial. This is the case when I is equal to 1. Okay, I is equal to 2. Just observe how the values get changed here. T is equal to minus 1, correct, into t. Now t is minus x cube divided by 3 factorial into x into x, I'm just substituting, right, divided by 2 into I into 2 into I plus 1. Okay, now observe, minus into minus becomes plus, so I will have x to the power of 5 divided by 3 factorial. Okay, now this denominator gets with this, so 2 into 2 is 4 into 2 into 2 is 4 plus 1, so this actually becomes 4 into 5. What does this represent? X to the power of 5 divided by 5 into 4 into 3 factorial is nothing but 5 factorial. Okay, so we got our first term, we got our second term. Now this will be added to our sum. Sum is equal to what? Sum plus term. So what was the previous sum? X cube 3 factorial plus x to the power of 5 divided by 5 factorial. On similar basis, for I equal to 3, I equal to 4, the terms are computed and they are added to your sum. We'll just have a look at the program. Okay, so observe here. Yeah, the same thing, I've written it in terms of syntax. Okay, yeah. For comparison purpose, I have also included the sinx function which is defined in your mat.h header file. I'll just run this code. Enter value of x is equal to 45 degrees. Value of n, I'll give number of terms to be computed as 5. Observe here, using Taylor series, I've got it as 0.7071. Using built-in function also it is 0.7071. I'll just run it once again. I'll just give 2 terms and see what happens. Yeah, 2 terms. Just observe. Yeah, here also I'm getting the approximate answer. Okay. Hope you all have understood this program. Thank you.